Hi and welcome back to a new video. About half a year ago we checked out a cooling unit by Q-Tec, which was advertised as a water cooling unit, but it turned out to just be an air cooler. Then doing more research afterwards, I found the KS70, which is an actual water cooling unit, just in an odd form factor. And we will have to find out if it still works and how it still works with recent hardware. That's what we will check out today. With a passion for IT and strong technical expertise, Hetzner delivers innovative solutions for demanding requirements worldwide. Operating its own state-of-the-art data centers in Falkenstein, Nuremberg and Helsinki, as well as cloud operations in the United States and Singapore, efficiency is always a top priority. The Hetzner server auction offers both standardized systems and individually configured servers that have already been in use, with no minimum contract period and zero setup fees. This allows hardware resources to be reused efficiently, extremely cost-effective and environmentally friendly at the same time. You can find all the information in the link down below. New customers can save $20 with the code DERBAUER20. The KS70 water cooling unit should be from about the same time frame, because when I was going through archive.org, I also found the first entries on Q-Tec about this unit from about 2004. Similar as the other CPU cooling unit, this one was also made back then for Intel Pentium 4. And Q-Tec was advertising that this is perfect for overclocking due to extreme high cooling capacity. It's also pretty interesting that Q-Tec was advertising that this is a closed loop system, which seems to be odd if you're looking at the pictures and you can see the tubing just going into normal water cooling fittings, at least normal for back at the time. And back at the time, this is 22 years old. I found two sealed units, but I'm not sure if they were sealed afterwards or if they are actually brand new and sealed. So that's something we have to figure out. But first I want to get a few reference values of our test system. It's running a 9800X 3D and just loaded export profiles. Everything else is stock. In Cinebench R23 under load, we can see temperatures just below 80 degrees Celsius that you can see right here on the CPU. CPU is pulling about 155 watts and is clocking at a speed of just below 5.2 gigahertz on all of the cores. And we are getting a score in R23 of 22,000 points. The second test I'm running is Remnant 2, this time in 4K resolution and ultra details, so very high GPU load, very low CPU load. The CPU temperature is about 46 degrees Celsius, now 47, and has a speed of 5,225 megahertz. Continuing with this, and you can see it's made for AMD, maybe not the right generation as what we have today, but it hopefully still works if we can make it fit. And I still find it interesting, it says closed water circuit, and then you can look at the image. And form factor wise, I think this appears to be 5.25 inch bay that was back in the days pushed in the front of the PC system. I'm not sure if this is actually new. I can see some marks that this was maybe opened before. That's our CPU cooling block. Seems like one of the top parts are missing. And I think the first thing to do would be to probably 3D print a holder to make this compatible to AM5. Half an hour later, that was just quick and dirty. I added an AM5 mount, just AM5 holes and a 52mm hole in the center to just fit on here. And that looks actually pretty nice. Not even bad. Still a bit concerned that this one thing is missing, and also not sure if those are residues on the top, but you can still see that the seal on the bottom of the block is at least still in place. I'm not sure what to think of this. There's like no air inside. I can't even tell if this is still liquid or if it's solid. Yeah, not sure if we will use that. That's probably the stock mount for back in the days, the old Pentium 4 CPUs. This could be unused indeed. At least I can't find any residues. If this was used, then you would probably have some green stuff somewhere, which I couldn't spot for now. And also found this missing boy. You can definitely feel that there is a certain aging that was going on with the tubing, and that concerns me especially for this one, where you can see at the point of the bend, both walls are basically fused together, and it seems not to be possible to release it. I will probably just open the second unit and see if the tubing looks the same there. It's also a good option to just investigate if the second unit looks the same way, like with the coolant and with the caps of the fittings, if they aged the same way, if there's just a problem with it, or if sitting 22 years in the box just caused looking like that. Appears to be fully identical, so it goes for the fluid and also water block. Yeah, top of the fittings also look a bit odd on this unit. The tubing has a similar problem, but luckily at a different spot. So here it is the short one that is affected with the tubing kind of being fused, but luckily the long one looks to be all right. So I can just remove that and then we can assemble one working unit. So that should be fine now. I took a look into the manual in the meantime, which is outstanding for the time it was made. Like details all the different sockets. Then comes to tubing, which then again is kind of weird when they're talking about a closed loop system, but you have to tube it. But that might have been different back in the days. Just comes for your definition. Then we have the filling, which I find cool because they say every 3 months or so you have to refill it. Refill the reservoir, which is this thing where the pump sits inside. And then another cool thing is this page where they're detailing all the individual components that are built in. That is pretty cool. And you can see the radiator, which is this piece of aluminum with the fans on top, the fan, the water tank, and also the pump with a small interesting detail that tells you that the water cycles through the loop once every 5 to 8 seconds, which is actually not that fast, especially considering how small the loop is. Manual also states that the bottom of the water block is made from copper with a die-cast aluminium top, and that also probably explains why they went for this automotive type coolant to avoid corrosion. And they also state that it has a W-shape fin structure. Not sure if I would call it fin structure, but probably just a W that was milled inside for cooling. We can probably investigate this once we're done. Now this thing is quite unique in how it's made. I think I've never seen a water cooling solution exactly like that before. It is definitely made for 5.25 inch base. So that was used back in the days, for example, for optical drives, like a DVD drive. And that is also why this could have been weird. Imagine you push this in front of your PC, push it into the 5.25 inch bay, and then you would have a DVD drive sitting above. Yeah, there is no clearance for the fan, so they would have a hard time getting any air through towards the radiator, which is sitting underneath. You see this just piece of aluminum, some fins in the top, and the water is probably just going in a like U shape through the aluminum. You can see that they sealed off some things right here. That is a typical thing they do on very cheap heat sinks, like this aluminum type heat sink, where they drill through and then just close it off with a piece of aluminum and glue it. And that's basically it for the radiator. And the blue thing that we already saw before is the reservoir. You can access this from the front, and then the pump is sitting inside there. And that's basically all the magic there is. Power supply is 4-pin Molex, and there's an additional small feature, which is this buzzer. And I think this was supposed to check the fan speed, like if one of the fans would fail, then it probably outputs some noise. Also just noticed those vents in the front, so I would assume that some of the hot air would just go out through the front. Cooling patch also still looks pretty decent. I also noticed this section which details the dedicated orientation of the CPU block, and that the wrong orientation can have worse cooling performance. And even this day, AMD CPUs, we know that they have a dedicated hotspot side, so that's pretty much on the bottom right here, which means I will also install the CPU block in that orientation. And I just want to use the same mounting gear of our CPU micro CPU block, and just put the block in there and then tighten it down with the plastic piece. Even looks pretty cool. So just have to add the tubing and then we should be good to go. All set up and ready to go. Only have to fill it through the fill port in the front. I'm just going to use distilled water, which is obviously not recommended, especially not for this kind of material mix, but honestly, I don't really want to try the green stuff. I also love the low and high indicator, which is like 1 millimeter difference from the front, and because of the curvature in front, once it hit low, it directly went to high, so all right. Yeah, there's a beeping, yeah. Yeah, that is super loud. Oh my god. I quickly removed that guy, but the pump seems not to be doing anything. Not sure if there's maybe some air still inside or anything. Huh. I'm just draining it again because I want to switch to the second unit where there was also a problem with the tubing, but I can replace the tubing from the left one to the right one, and then hopefully the pump will work on this one. I also noticed this pump alarm is detailed in the manual. So the small thing that was super loud and annoying was pump alarm, and it worked because the pump was not working. I replaced everything, swapped the tubing. Now I have to refill it, and then we will just try again. I will probably put this back in. Yep, there was only a short beep. So pump alarm was probably starting, and I can hear a rattling noise that I couldn't hear before, so definitely different. I can see some bubbles very slowly moving, but I can see something moving, so that is great compared to what we saw so far. Yeah, flow rate is different, I would say, but at least the pump works. So that is a big plus over the other units. And I think I will have to add a little bit more water into the tank. It's definitely working. I could see a few bubbles just coming out of the tube, so I definitely know it works. We got it working, and I think it's not even bad. I also added a temperature sensor on top of the CPU block, just to the aluminum housing. That should give us an idea of the water temperature. We're approaching about 33 degrees Celsius water temp, which is definitely not bad. And you can see I'm already running the gaming test. And in Remnant, just right now, it's like 54 degrees Celsius. That is, for this type of cooling, for this age, that is impressive. A couple of minutes later, and we have a 35 degrees Celsius water temperature, still in an absolutely okay range. And I want to test the gaming now. This would be absolutely playable. Most of the time reaches just below 60 degrees Celsius on the CPU and the 5225 MHz, which is the desired CPU clock. Yeah, that would absolutely work out. Cinebench might be more of a challenge with 155 watts. That's about twice as much as what we saw in gaming. Instantly reaches the limit of the CPU, 95 degrees Celsius, which means that it will no longer be able to maintain its max clock. We will definitely lose some performance. You can probably estimate it already by looking at the CPU package power, which dropped from 155 to about 145. Still running at the 95 degrees Celsius. And just about 5 gigahertz of clock on the CPU, resulting in 20,600 points. So we lost about 1,300 points, I would assume, which is not as bad as I expected. Cinebench is a pretty short test, which means that the system, just by its mass, by the water, can buffer a lot, even without dissipating a lot of heat through the radiator. That is why I'm now running Cinebench with a 30 minutes test. And then we will check in between how much heat the system, the radiator itself, can dissipate. I also almost can't hear the pump anymore, just probably some air was trapped inside the pump. The only thing I can hear are the fans, but they are also not that loud. And considering the time it was made, I think back then it would have been a super silent cooling system. It has been over 20 minutes and it's better than I expected. We are reaching 54 degrees Celsius, which is lower than I expected. You can see in Cinebench, just above 20 minutes under load, and we have a constant load now on the CPU of about 100 watts. Of course, we still have the 95 degrees Celsius that is expected. It's just a temperature throttling, and we see a clock still of about 4.5 gigahertz. Almost forgot that I also want to check out the internals of the block, so I just removed the screws. We can take a look inside. Yeah, it's a big aluminum cover. And then underneath we have this W shape they were talking about. So very simple cooling structure, just flows in, goes in the W shape and back out. If you would have asked me in the beginning how much this can dissipate, I think I wouldn't have called it above 100 watts. So I'm actually impressed also by the noise level. Especially if you go back 22 years, I think this would have been a quite impressive cooling solution, especially for the time. Most of the cooling solutions back then, especially air coolers, they were quite noisy. So this one is pretty much an exception, and I think back then delivered quite a good performance for what it is. But for today's standards, it's the form factor that kills it, like 5.25-inch bays are basically dead. They no longer exist. There are no cases that still support this, or almost no cases. But considering the time, I'm impressed. I think, especially because of the noise level, this is quite cool. I liked this one. I also hope you liked this video. Thanks and see you next time. Bye bye.